product of non-enzymatic interaction of N-terminal valine of beta chain of hemoglobin and glucose. For this, we have HbA1c and we have a very learned speaker, Dr. Sujoy Ghosh, who will be taking this talk.
Thank you, sir. I have about 20 minutes to finish this talk, so I'll try to be as brief as possible and quickly go through bits. I will concentrate predominantly on how to interpret a graph of an HbA1c. Actually, one of my juniors told me, Dada, ye jo graph deta hai na, how do you interpret it? Because when you're looking at the report of HbA1c, you look at it and you pretend you understood everything and you start prescribing. Patients bolte hain, sir, दूसरा graph नहीं देखा आपने. So you pretend that you've seen the graph, but you don't know what you've seen in the graph. So that's the reason I'll actually demonstrate how to look at the graph. But prior to that, about 5-10 slides, very quickly about the basic background of HbA1c and how the world is changing in terms of interpretation of HbA1c and reporting of HbA1c. So, respected chairperson has already given you the basic background of what essentially HbA1c is, and we have always been taught that, if you're looking at HbA1c, it tells you approximately what has happened in the last 3 months or so, but remember with 50% weightage of what has happened in the last 1 month. So all the 3 months don't have equal weightage. And a little bit of chemistry. Sorry, it's got all jumbled up, I don't know why. The A1, HbA interacts with the glucose non-enzymatically to form a labile compound, which is a Schiff base and an aldamine, and then becomes stable to form a ketoamine. The reason why I'm talking about this labile A1C is, if there is sudden changes in blood glucose, you might have a higher proportion of labile A1C, which might actually interfere with the reporting of HbA1c. There are two ways: either you manually wash it off, or there is an automated system of washing, so that does not interfere with your interpretation of A1C. It's important. And the incubators, there are other methods of A1C estimation apart from the HPLC. But HPLC is what we use as gold standard, though there are issues with HbA1c, with HPLC as well. Renal dysfunction, this will interfere in your interpretation of HbA1c as well. So I've already told you that about 50% of the contribution comes from the last 1 month, and you can see 4 months ago kya hua tha, even that contributes. So it's not a watertight compartment. Now we have also been taught that it corresponds to estimated average glucose. That's probably validated in the Caucasian population, but we don't have much of an Indian data. And remember, there can be a concept of slow glycators. A1C average corroborates with. Again, this is with a pinch of salt, because your patient might not have the same kind of glucose control in the last 3 months. It might have been better or worse in the 3rd month previously and now. And again, the reason I'm bringing this up here again is, a lot of you are doing ambulatory glucose profile and you look at estimated glucose readings. That's again very, very fallacious and is an overestimation of what the reality is. Now, the 2007 consensus, the ADA, the IDF, the ESD and the International Federation of Chemical Chemistry came up with a consensus. They decided that, we are all reporting A1Cs as percentage, 6.7%. We will now in future start reporting in millimoles per moles as well. This has still not happened in India due to whatever reasons, but you will now see every paper that is published in Diabetes Care will have both the readings. And it is mandatory when you are submitting to an international journal that you are reporting in millimoles per moles as well. In future, it is anticipated that people will only report in millimoles per moles, and I will tell you the results and the reasons for the same. Now, we all started talking about HbA1c after the DCCT trial, right? Because that was the first big study which talked about HbA1c as a marker of whatever control we are talking about. Now, there were 32 centers in USA that were doing the DCCT study, and everybody was doing a different method of estimation of HbA1c. Now, how did they decide which one was the reference method? जिसके पास patients ज़्यादा था, उसने कहा मेरा method ही सही है. So everybody started recalculating their value according to what it would have been had it been done by that particular center. So you will see your reports saying DCCT aligned. The reports from the good labs you will see say it's DCCT aligned. It means if that test had been done by that method, this is what the results would have been. Now with the advent of technology, we know the pure method of measuring A1C that we have now will give a 2 percentage point lower reading. So what was 7 by that DCCT method is actually 5. Now imagine the confusion. From today, if you start using the good method and start reporting on the basis of the good result, you will start saying it is 5 and not 7. What happens to medical literature? How will you know pre-2023 versus post-2023 publications? You cannot compare. So people said, okay, we will still measure the percentage, but by measuring it in the pure method, we will report it as millimoles per moles. That is a pure method that the IFCC has come up in measuring. And this is one of the editorials that I wrote with my professor in UK in Diabetic Medicine Journal about this particular change in the A1Cs. And as you can see here, what was say 5% is actually 31 in millimoles per moles. Now how as a clinician will you remember the interconversion? So remember a trick. So if you say it is 7%, 7 minus 2 is 5. 5 minus 2 is 3. Put the two digits together, it is 53. So minus 2 will give you what the new results in millimoles per moles of the A1C will be. Now, next comes the question of sample collection and storage, because you know pre-analytical errors are very common when you are doing tests. Good thing, patient does not have to fast. You take a venous sample and you put it in an EDTA vial, and the whole blood can be stored at 4 degrees centigrade, standard fridge for 1 week. If you are keeping it in a minus 70, you can keep it for a year and a half. Heparinized samples should be tested within 2 days. The reason why I am saying this again is why you keep it in an EDTA blood? Because you want to take the whole RBC, take it to the lab, hemolyze it and get the hemoglobin out. Because you are going to check which bit of it is glycated. If it's a hemolyzed sample or a damaged sample, or if it's a clot blood, obviously it's not going to work. So when the juniors ask you, sir, A1C bhejna hai, kisme bheje? Because rest of the test, most of it is clot blood. So if you want to send an A1C, it has to be an EDTA blood. The sources of errors. Now, we all know that there is something called analytical error or CV of coefficient of variation. What I am trying to highlight is even a 2% error will give you an error of A1C of 0.5. So you understand this is a test that needs good precision. That means your lab has to be good. Otherwise, don't do the test. And there are 49 different variants that are reported which will interfere with your HbA1c assay. In a country like India where you have so much of hemoglobinopathy, particularly Eastern India, hemoglobin E disease, even if it's not beta thalassemia, is very, very common in India. So you have to remember how to detect that interference. So if you look at the NGSP website, which is the mother of all websites for HPLC for A1Cs, whichever machine your lab has given the test, you should go and see whether they are actually interfering with the common hemoglobinopathies that are there in India. Otherwise, you will not know. The commonest lab that machine that we all use is the Bio-Rad D10. And it says it does not interfere with these, right? There is a catch there. It does not interfere with homozygous mutations. But heterozygous it will not interfere partially perhaps, but homozygous definitely there will be interference. And you can have a look at all of the systems that we are currently using. Now, a lot of people will come to your lab and say, particularly for pharma, "Mera point of care machine hai sir, badhiya hai." You will see most of them are not validated. Most of them have interference with these variants that I am talking about. So this is the HbA1c graph that I was talking about, right? Most of us don't know how to make head or tail of what is here. Kya likha hai? Kaun jane? So let me try and break this up. So this is what it looks like, right? There is something called peak, something unknown, A1A, A1B. LA1C is labile A1C. CHB1 is carboxylated hemoglobin A1C. All of you are already experts, you know how labile happens, how carboxylated happens. P3 is what gets degraded. So if your storage is bad, your transportation is bad, the P3 will increase. And your A0 is your normal, non-glycated hemoglobin. And at the bottom you are getting a reading. So this is what a normal graph looks like. Now, if you are trying to interpret each of them, the first thing to look at is the baseline of the graph straight. If it is not straight, you cannot interpret the result. That means the chromatography is wrong. Then you are supposed to look at the retention time. Basically, this is a chromatography, right? If it is not moving at the right pace, then that chromatography is also erroneous. So these are relatively less important sources of error. Now I told you here P3. Now P3 denotes the level of degraded hemoglobin. The older it is, the worse it is. And ideally it should be less than 10%. If it is more than 10%, please don't look at the graph. That means half of the sample was already hemolyzed. So you don't know what is happening. The next thing to look at is retention time. The various hemoglobins move in the column at a specific charge, and therefore you are supposed to look at the retention time is normal or not. Then you are supposed to see if there is a hemoglobin F peak coming here. It will be reported, HbF, because there might be some fetal hemoglobin that is persistent. It has to be less than 10%. I told you about the labile A1C and the carboxylated. It has to be less than 4%. Otherwise, even that interpretation is wrong. So here, for example, you can see the labile of the carboxylated is 12%. So you will not interpret it. And again, outside the range. This, you can see the NGSP with the Biorad D10. The maximum hemoglobin that you can report is 18.5%. It is like a weighing machine. Your weighing machine can weigh say 150 kilograms. And you are saying that the weight is 170. Is it possible? So what is the range in which it actually can report? So with that in background, let me now show you real life cases. The quality of the graphs might not be always great, but at least I'll try my best. So this is case 1. So I'm just telling you the HbA1c is reported as 20.1%. Is it possible? I have already told you the upper range of detection of the machine is 18.5. So it is above linearity. Therefore, this report should not be interpreted unless and until you are diluting the sample and repeating the test. So it's above the linearity and therefore not to be looked at. This is what I was already talking about. Case number 2. You can see there's something called an S window, which is 38%. What does that mean? That means there is something interfering in this HbA1c. So this HbA1c of 7.4 cannot be interpreted. This is sickle cell disease. Therefore, it has come up with something called S window. Let us look at the next one. It says variant window 40.4%. So I've told you, and A0 is only 46%. That means this patient has got an interference with some kind of hemoglobinopathy. The D2 machine is the same machine. The Biorad D10 machine is the same machine which does both your thalassemia screening as well as HbA1c. So whenever you find something like this, you are supposed to run it in the D2 mode. This is the D1 mode which gives you the A1c. The D2 mode tells you which hemoglobinopathy is it. So this is again another variant. Look at the HbA1c, it is 0. This is classical of hemoglobin E disease. Because the hemoglobin E, if you look at the variant window itself is 80.9. That means the hemoglobin E elutes on the chromatography exactly to the place where HbA1c is supposed to elute. And therefore you are getting an HbA1c of 0%. You know that there is something wrong. And then if you look at this particular one, you can, I don't know whether you can make out, F says 15.5%. I've already told you the fetal hemoglobin has to be less than 10%. If it's more than 10%, the report is not interpretable. So I've already told you, if somebody has a bilirubin more than 20, don't interpret the report. Triglyceride more than 5,600, don't interpret. Fetal hemoglobin more than 10%, don't interpret. Levile hemoglobin more than 4%, don't interpret. Carboxylated more than 3.5%, don't interpret. Now this is again another patient. You see that the HbA1c is only 2.7%. Now it's always good idea to interpret the report in the light of the patient, not just ये देखा और समझ लिया कि इस patient में क्या है. Look at the hemogram of this patient. This patient has got low hemoglobin. This is someone who had a chronic liver disease, had a GI bleed. Now you have given blood transfusion, and you are seeing low HbA1c. Is it right to interpret that report? Because most of the hemoglobin that he has is not his. It is transfused hemoglobin. So, inappropriately low, there is a long list, inappropriately high, there is a long list, and variable effect. You have a long list of interference in interpretation of HbA1c. And remember the drugs that either push it up or push it down. Don't forget that. The next, as you can see here, the HbA1c is 54.2%. I did not know what to do in this patient. And then I went up and read up literature and found that there is something in Kerala that happens called hemoglobin hope disease. I actually went back and traced the family, and several of the family had hemoglobin hope disease, which means that the HbA1c जहाँ पे elute होता है, this just goes and elutes on top of that. So this hemoglobin is interpreted as hemoglobin A1c. So we published that as well. The next, again, here you can see the variant window is about 50%. I told you when something like that happens, you run a T2 mode and you find that this is hemoglobin D or Iran disease. The next, as you can see, this is someone who's got a PP sugar of 220, but A1C is very high. And if you look here, we've not been able to find a variant window of beta thalassemia or beta chain, because the beta chain is where most of the hemoglobinopathies happen. So I sent this for genetics, and this turned out to be an alpha thalassemia. Very, very rare. You can see the alpha peak there. We did the genetics. The next, as you can see, is someone who's got renal failure, type 1 diabetes, renal failure. And hemoglobin is 5.1. You might start thinking that this is very good control. But if you look here, the labile carboxylated is 26.1%. So that is why there is interference. Again here, another case of persistent hereditary fetal hemoglobin, 25%. And the final case, 18-year-old lady comes in, type 1 diabetes, admitted with menorrhagia. A1C is high, but the readings are not that bad. So this is someone who's got iron deficiency anemia from bleeding. And as a result of which, God is trying to protect the individual and prolonging the lifespan of the RBC and saving the person. Again, renal failure can cause problems. So I think my time is almost up, but I'll finish by saying that we need to talk within the departments. We find a blood report or something and it doesn't match the clinical presentation, we start blaming the pathologist or the biochemist. It's perhaps our ignorance that we didn't know that such things existed. It's always a good idea to call up and say, I don't know, I don't understand what's happening. Can you please explain? Interpret the report in the light of the entire story. The history, the clinical presentation, the other drugs. An unexplained report does not necessarily mean that it is wrong. It is okay to put your hands up and say, I don't know what's happening. And in situations like this, use other technology, use immunoassays, use an SMPG or home reading to find out what's happening. And I'm quite certain I have presented only 10% of the cases that I did not understand. The rest 90% is still there for me to learn. Thank you very much. See what the glucose control is like. Why wait for such a long period of time, even 3 months, to figure out whether they want to improve? And the other issue is